Welcome back to the course on information theory. To recollect, we have already studied about the concept of information theory, the measure of information theory, how it is related to probability of occurrence of an event or uncertainty of an event. Then we looked into the categories of different information sources like discrete information source, continuous information source. Then we moved on to the channel capacity theorem. Lastly, we studied about the entropy in connection with information theory. Now today we are going to study about the layer view of digital communication system in connection with information theory. Let us look at the diagram. A digital communication system consists of majorly three parts. The first part is the source, which actually generates the information. The second part is the channel through which the information passes, and the last part is the destination where the information actually goes. Now let us look at the first part. The input to the source encoder. Why do we need a source encoder at all? The input can be any message having any probability of occurrence. Now, in order that we transmit it through the channel, we have to convert it into a format that is compatible with the digital channel. In order to do that, we have used there a source encoder which normally converts our messages into bits of information. Next, we have the channel encoder. Now, why do we need the channel encoder at all? Actually, the channel is weakest, or the signal is weakest at the channel. Now, what is a channel? Actually, when we move from our home to our office, we take a road to pass. In a similar fashion, when a signal has to pass through a system, it has to take a channel. Now, what do we mean by a channel? Channel is actually the frequency with which the signal is actually passing. For example, when we tune a television or tune a radio to a particular station, what are we doing? We are actually selecting the particular frequency which actually transmits the signal. The no two frequencies should overlap between the two stations, otherwise there will be crosstalk or interference between the two signals. So that is the channel. Now, since the signal is weakest at the channel, it can be hit by noise. Now, since we are dealing with digital communication system or the digital data, whenever a noise hits a signal, a 0 can be changed to 1 or a 1 can be changed to 0. So there will be error in the transmission of the signal. So if we transmit 0, 0 from the source, it may so happen that at the receiving end, due to noise, the signal may not be received as 0, 0, but rather 0, 1. So there we find there is error in one bit. Now how to reduce this error? For that reason, we have used there a channel encoder. What actually it does? It actually keeps a redundant bit, one or two redundant bits, which according to some algorithm, if we calculate it, we will be able to identify whether a signal that is getting passed through the channel is erroneous or not. Now, since the bit is redundant, when it goes to the receiving end, after we have identified the error, if the signal is erroneous, we will discard the signal. Or if it is not erroneous, we will take the signal and discard the redundant bit that has been added for the channel encoder system. Now, after the channel encoder comes the channel. Now, after the channel encoder, we have zeros and ones. Now, these zeros and ones means the voltage levels. These voltage levels cannot pass through the channel on their own. Now, what do we need to do about it? Just like we take a taxi or a cab or a bus or a car to pass through the road, in a similar fashion, the bits has to be incorporated into some form of carrier so that it can pass through the channel. Now that is called modulation. What we do, we take the bits and we superimpose it on a high frequency carrier signal having a particular frequency, and that will enable the signal to pass through the channel. Now after the signal passes through the channel, Having been source encoded and channel encoded, it goes to the receiving end. Now since we have done channel encoding, at the receiving end there must be a block which will do the channel decoding. In this decoding, we are actually discarding the redundant bits. But before that, before the channel encoder, we have already modulated the signal. I have not shown it over here, but since we have modulated it, we have to demodulate the signal in order to get back the original message signal. Now after the channel decoder, where we have removed the redundant bits, we have to go to the source decoder, where we will just decode the sources to get the particular output that has been actually transmitted through it. So there goes the layered view of digital communication system. Now for source encoding and channel encoding, there are various algorithms which we will study in the next lecture.